Okay, so yeah, get those special angles with the radians written in there, and then the equivalent forms of those, okay? And we're going to use those in order to solve, to do some of the work on these types of problems, okay? I want to point out a couple of things about the formulas first, and then we'll actually kind of get started on solving, okay? So we're going to look at what's referred to as the sum and difference formulas. Today we are strictly just going to look at cosine and sine. We're going to do a tangent the next time we are together. Okay, so some things to notice. No, you do not have to have these memorized, but it is helpful if you are somewhat familiar with what the formulas say when you're working with these. So notice on the cosine formulas, the cosine values, the cosine of the angles are together and the sines are together. When we look at the sines, if it's plus here, it's minus there, and if it's minus here, then it's plus there. So those signs switch, right? Okay, cosines are together, sines are together, and then we have to decide on the sines. Whereas if you look at the sines and cosines are kind of mixed together here, right? We've got sines and cosines together, sines and cosines, and the positive and negative signs correspond in each place on the left hand and the right hand side. So kind of just some things to kind of pick up on and notice on each of those different formulas. Okay? So the idea here, this is kind of one type of typical problem that you're going to see. The idea here, it says find the exact value of cosine of pi over 12. That means we went radical. We're not just going to plug that into the calculator. So we will use some of our radian measures that we need to combine them by either adding or subtracting in order to combine together to get this 1 pi over 12 that we are looking for. So we've got to decide what two fractions do we want to use here so that when we combine them together we get 1 pi over 12. Thoughts, ideas, what do you want to try?
4 minus 3.
Okay, so Chloe's saying let's do 4 pi over 12 minus 3 pi over 12. Let's do that. Okay, so this cosine of pi over 12, we're going to rewrite that as the cosine of 4 pi over 12 minus 3 pi over 12. Now, we're about to have to plug into this formula up above here, though. And then we're going to have to go to our unit circle. So it's going to be easier if we have these angle measures, these radian measures written in terms of our basic 4 pi over 12 we know is equivalent to pi over 3, and 3 pi over 12 is equivalent to pi over 4. We want to rewrite it so that we've got those values in the problem so that we don't make any careless mistakes there. Okay, so I'm going to rewrite this again with this pi over 3 minus pi over 4 before I plug into the actual formula. Okay, does that make sense?
Why do you do minus 3 pi over 12 again?
Say that again.
Why do you do minus 3 pi over 12?
4 pi over 12 minus 3 pi over 12 gives us the 1 pi over 12 that we're trying to get. Do you see that? Okay. All right, so the formula tells us if we're doing cosine and we've got subtraction there, look right above. It's telling us we're going to do the cosine of pi over 3 times the cosine of pi over 4. And then it's going to be plus the sine of pi over 3 times the sine of pi over 4. Thank you for waiting. Go ahead. Okay, so do you see that? Where I'm getting that formula from? We're just plugging into this formula right here. Chris, yes, you need to get this written down. Yeah. You're going to want this as reference for sure. Now we've got to go to unit circle. Remember, cosine values are our x coordinates. Sine values are the y coordinates. So if I'm looking for the cosine of pi over 3, what does that equal to, Jaden?
Cosine of pi over 3?
Yep.
Yeah.
I'm sorry?
Is it 1/2 or is it?
1/2, okay, yes. You do have,
Oh, yeah.
you have your own, you were just looking there. Okay, all right, so cosine of pi over 3 is 1/2. Cosine of pi over 4, Chatham? Root 2 over 2, right? Good, okay. And then plus sine of pi over 3, Campbell?
Root 3 over 2.
Root 3 over 2 times sine of pi over 4. Braden, what do we get for that?
Root 2.
Root 2 over 2. There you go. Okay. We've got to clean up this math now. So when we multiply fractions, remember we multiply the numerators, multiply denominators. So we end up with root 2 over 4 plus root 6 over 4. The tendency is to feel like you should be able to combine like terms or something, but you can't. Really, the only other thing you can do to clean this up a little bit more is to write it over that single common denominator there. So root 2 plus root 6 all over 4. So kind of weird looking, but that is the exact answer. That's the format that you are going to see for this type of problem. Okay. Questions kind of on the process there? Okay, then let's look at this next one. If we're doing cosine of, it's easier when it's degrees like this because it's easier to look at the unit circle and decide on special angle measures. Any two angle measures that are either going to add or subtract to give us 75. What do you want to use? Chris, what two angles should we use to get to 75? Can add or subtract to get to 75. Okay, we can do that. Okay, so whoops. Cosine, let's write it as 45 degrees plus 30 degrees is what he's suggesting. And so then we've got to plug into the formula up above. So the formula up above with the plus there and inside here tells us we're going to have minus over here. So our cosines together minus sines together. So that means we're going to have cosine 45 times cosine 30 minus sine 45 times sine 30. And then we're going to unit circle. So cosine of 45, Grayson, what do we get?
Root 2 over 2.
Root 2 over 2, good. Times cosine of 30, Sebastian, what do we get? Where's your unit circle?
Root 2 over 2.
Root 3 over 2, good. Minus sine of 45, Ryan?
Sine of 45 is root 2.
Root 2 over 2, Leo, sine of 30?
Sine of 30 is square root 3 over 2? Or is it 1/2?
1/2, right? Yeah, sine of 30 gives us the 1/2. All right, look again at what our answer ends up being. We get the square root of 6 minus the square root of 2 all over 4. Are you kind of noticing a pattern here on what your answers are going to look like for a cosine problem?
Yeah.
For better or for worse, guess what? Our sines, if they're that exact same format, will look exactly like that also. So essentially what you're doing when you're solving these is figuring out whether they are positive or negative signs in front of them. So someone earlier was like, well, you got a 25% chance. Can't we just guess? You can, but it's a little bit easier and a little bit more surefire if you actually just do the work. Campbell.
I figured, wait, actually, why did you put the denominator to 4?
I'm multiplying these two together. So common denominator is 4 when we multiply those, right? Okay. So formulas are a little bit different for sine, but they're going to work exactly the same way. I want you to notice, though, this next problem is a little bit different from what we were just doing. I mean, these up here, you were given an angle measure, right? We had to add or subtract to get that. This one, if you notice, it's giving us values already and we just have to prove. So this is similar to what we've been doing where, okay, we obviously need to work on the left-hand side because it's the more complicated side. And we're going to have to plug into our formula. Now notice we're given an x. X could be any value, so we're going to keep the x in there. We're not going to put a number in there. X could be any value that you think of. But we're doing sine of two values that are being subtracted. So that's like this up here, which means we want subtraction in between there also. So we kind of mix these together. So that means we're doing sine of pi times the cosine of x, and then minus the cosine of pi times the sine of x. So be careful plugging into that one. You don't want to end up putting the exact same thing in each place accidentally, or you end up zero, and that's not what's happening. All right, now we need to go to unit circles. So the sine of pi, Alicia, what's that equal to? 0. So we have 0 times the cosine of x. Guys, what's that equal to? 0. And then minus, all right, the cosine of pi. Davis, what is that? -1 times sine of x. So this minus a -1 becomes plus 1 sine x, or just sine x. So we get that sine x is equal to sine x. So we have just proven that identity. Okay. Comments, questions on that? Hopefully that makes sense. I think it's pretty straightforward, but it's also easy to make some silly mistakes, so you just have to be. We are not going to look at tangent today. We're going to do that next time we are together. But if you notice, this top problem is a sine and cosine type problem. So we're basically going in the reverse on this one, right? If you notice, it looks like the right-hand side of our formula or our equation. So the thing to pick up on is the fact that we've got sines and cosines mixed together. So we got to go back and look at our formulas. Does that mean this is a sine of a sum or cosine of a sum or a difference? Okay, so it means it's a sine. And we need to decide on the operation. This operation here is plus, so what does that mean goes? Yep, so that means this is plus also, right? You got to go back and look at your formulas to kind of pick up on the fact that cosines and sines are mixed together, and it's plus, so it means it's plus here. So then we're just putting those angle measures in. Guys, a little hint, a little trick. If when you combine those numbers together, you don't get an angle measure that's on your unit circle, then you know you've done something wrong, right? This adds and tells us we're really looking for the sine of 90 degrees. Yes, you want to give me the answer to that, which is just 1. Okay. One last problem we're going to look at, and then I'll explain what you've got for classwork/homework. Just a second. Can you hold on, Alicia? Okay. Let's look at this one. So we're on page 15. I'm seeing sines and cosines combined together. So we're going to do the math here. We're going to go to unit circle and actually figure that part out. But we can also kind of work the other direction and say, okay, that means we're doing sine of two amounts. Are we adding or subtracting between those two? We are adding, and we want to put in those angle measures. Pi over 3 and pi over 4. So if we add those, if we add pi over 3 plus pi over 4, and we think common denominator, then this is equivalent to 7 pi over 12. So you, on these, if you're given this type of thing, you can kind of work both directions, work backwards towards the left. We're actually going to finish solving it though too. So this should give us the answer for sine of 7 pi over 12. All right, so sine of pi over 3, what do we get, Chatham?
What did you say?
Sine of pi over 3.
1/2. Oh shoot, radical 3/2.
Okay, root 3 over 2. Okay, times cosine of pi over 4, Aiden?
Pi over 4,
Yep,
root 2 over 2.
root 2 over 2, good. Plus, and then cosine of pi over 3, Sebastian?
Square root 3 over 2.
Cosine.
Oh, 1/2.
1/2, good. Times sine of pi over 4 is going to give us root 2 over 2 also. So we combine this together and we get our root 6 plus root 2 all over 4. Okay? All right, so classwork / homework. Yeah, sorry.
So it's two different ways to solve this.
Well, it kind of just depends on what they ask of you, whether they want you to kind of work backwards and come up with that part of it, or whether they want you to actually simplify and come up with that.
That'd be interesting. 5 and 6 to 5.
Yeah, so all of these sines and cosines, they're gonna have a root 6, a root 2, and over 4. Guys, that's the beauty of this, is that if you don't get that, you know you've done something wrong, right? So your classwork and homework is the next couple of pages. There are some tangents mixed in there too. You're not doing those, obviously. You're just doing the sine and cosine ones, okay?